current in this whole loop is nothing but I1. So if I simply apply KVL equation, so whatever mesh we have, let us apply KVL in that mesh. I'm going to travel in clockwise direction. The first voltage will be 4 volts as I'm going from negative to positive terminals of the battery. The second drop will be across 2 ohm resistance. I'm traveling in the direction of current, so drop will be negative minus 2 I1. The next drop will be across 1 ohm resistance. Again we will be traveling in the direction of current, so it will be minus 1 into I1, and this is equal to 0. So once you solve it, you get this will be 3 I1 equal to 4, and this gives us the value of I1. You can see I1 is going to be equal to nothing but 4 by 3, which will be 1.33 amperes. So that's the first value that we have got for I1. Likewise, now we find out the remaining two values of current I, this time due to the two current sources that we have in the circuit. So that's step 1. Let us now proceed to step number 2. So we consider the original circuit once again, and in step number 2, I'm going to keep 1 ampere current source active. So keeping 1 ampere active. So we will have to now replace 4 volt source and 3 ampere current source. We already know that to replace a voltage source, we have to replace it with a short circuit. So I'll just remove this 4 volt source and connect a short circuit in place of it. And how do you replace the current source? We all know that to replace the current source, we have to simply remove or make it open circuit in a given circuit. So this is my modified circuit diagram in which only 1 ampere is kept active and the remaining sources have been replaced. So the current through 1 ohm resistance in the downward direction that we have to find out, we will now call this current I2. I2 will be the value of the current only due to 1 ampere current source. Now let us find out I2. As I told you before, one can apply either mesh analysis or nodal analysis. Now in this case, you can see this particular mesh is open and hence there will not be any current flowing because there's an open circuit on this side. This is one mesh and this is one mesh. So there are two meshes in case we plan to apply mesh analysis. Also, because there's a current source in this particular mesh, you will directly get the value of the current in this particular mesh. So if I define current in this mesh as, let's say, IA, in that case we directly get the value of IA. IA is nothing but 1 ampere. So all I have to now do is write down KVL in this second mesh which is available. I will travel in the clockwise direction. Let us first travel through 2 ohm resistance. If I travel towards right, then I must define the equivalent current through 2 ohm resistance which is also flowing towards right. You can see current I2 is what will also flow in this particular mesh because this mesh has resistance 1 ohm which is completely part of this mesh. This 1 ohm resistance is not being shared by the other mesh. Current in the adjacent mesh is 0 and hence the current in 1 ohm resistance, which is I2, will also be the mesh current in this particular case. So current through 2 ohm resistance will be I2 in right hand side direction, IA in left hand side direction. So if I want to define a current that is flowing towards right, it will be nothing but I2 minus IA. And because we are writing KVL traveling in the same direction, in the direction of current, the drop will be negative. So let me write KVL in second mesh. So KVL in mesh 2 will be minus 2 into I2 minus IA minus, now if I come down, I will write the drop across 1 ohm resistance. If I travel in the direction of current, the drop will be minus 1 into I2 equal to 0. Replace IA with its value which is of 1 ampere, so we get minus 2 I2 minus plus 2 IA. IA is equal to 1 minus I2 equal to 0. This gives me minus 3 I2 plus 2 equal to 0, and that means I2 is equal to 2 by 3 and 2 by 3 will be nothing but 0.667 amperes. So that's the second value of the current that we are looking for. This is the value with keeping 1 ampere current source active in the circuit. Now we have to go through one last step, in which case we will keep that third source, which is the second current source, active, and we will replace the other two sources like we have done in this particular case.